Okay, so I'm going to walk you through what you need to be able to do for the quiz next week, okay? So first, there's a position time graph, and you can see that it's a parabola, all right? So what that means is that this object is getting faster and faster as time goes on, all right? So you can see that because in the first 2 seconds, right, the position increases by 5 meters, okay? And then in the next 2 seconds by 7 meters, 9 meters, 11 meters, etc., right? So see, every time an equal time interval passes, the position change is bigger each time, okay? That's what makes this object be speeding up or getting faster, okay? Don't just say accelerating, right? Because remember, that can mean slowing down. So you want to say speeding up, ideally also in a positive direction, right? Because the position numbers are getting bigger, okay? All right, 2 ways you could find the instantaneous velocity at 5 seconds, all right? Okay, one way is you could draw a tangent line, okay? Tangent line, and then you have to say find the slope, right? Because just drawing the tangent line doesn't do anything for me. You have to find the slope of the tangent line, okay? And then that would tell you how fast this object is going right at 5 seconds on the dot, all right? The easier thing to do, or another thing you can do, is if you take the slope of 2 points, okay, equal time away from the one that you want. Okay, so in this case, away from 5 seconds. You could take the slope from 4 to 6, or 2 to 8, right, or 1 to 10, right? You could take the slope of any of these numbers, okay, that are all equal time away from 5, right? And then that tangent line, those are all the same line. All right, so that's kind of a little bit easier way to do it, okay? But please make sure you say slope. Whoops. Okay, please make sure you say slope. Don't just say draw the line, okay? All right, now we're going to find the instantaneous velocities at a couple of these times, okay? So time 2, 6, 8, all right? So at 2 seconds, at 6 seconds, and at 8 seconds. And I'll be expecting to see this work, all right, on the test. Okay, so if I want 2 seconds, right, then I need the slope of 2 points equal time from that. So I would probably use 0, 4, and 4, 16, okay, because those are each 2 seconds away from 2 seconds, okay? And then if I do slope, y2 minus y1 over x2 minus x1, so 16 minus 4 over 4 minus 0, okay, that'll be 12 over 4, all right? And units-wise, right, these y values here, oh, I keep hitting the eraser, ugh, okay? These y values here are the positions, okay? And then the x values are the time, okay? So this is going to be 3 meters per second. Okay? All right. At 6 seconds, we can do it for more, okay? But we don't need to do it for all of them. So the next point I want is 6 seconds. So I want to use 2 points equal time from 6, okay? So that would be 4:16 and 8:36. All right, so if I do the same thing, 36 minus 16 over 8 minus 4, okay, 20 over 5, no, 20 over 4, okay, and then that's going to be 5 meters per second, okay, so that was how fast it's going here, okay, and then at 8, all right, I can use these 2 points, so I could use 6:25 and 10:49, okay, and then that would be 49 minus 25 over 10 minus 6, or 24 over 4, or 6 meters per second, okay? All right, so now I have some points I can use to construct a velocity graph, okay? So make sure you can find those instantaneous values, okay? All right, I'm going to erase these so I have some space to draw, okay? All right. Now I want to use those points, okay, to make my graph. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so on the test, right, you'll have it a little bit better. So 0, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. Okay, so make sure that you label this. This is the velocity, and this is the time, right? So let's look at what points we have. So we have 2, 3, 6, 5, okay, and 8, 6. Okay, so I'm going to have here, I hope my y-intercept comes out okay. It's a little bit hard on here. Okay, so I'm not sure where that's going to cross. Maybe we'll have to see. I might have to look at the chart. Let's see if it crosses there. If not, we'll have to adjust it. Okay, all right. Yeah, all right. Okay, so here's my velocity graph. So the slope of this graph tells me the acceleration. All right, so if I look at this, I can look at the table or at the graph. Okay, so I can see I'm getting 1 meter per second faster every 2 seconds. Okay, I'm getting 1 meter per second faster every 2 seconds. Oh yeah, see, I think this maybe is going to cross wrong. We'll have to go back and see. Okay. Yeah, see, because here's 2 meters per second in 4 seconds. Okay, or 2 meters per second in 4 seconds. Both of those are a ratio of 1/2 meter per second every second. Okay, so every time I go over 1, up a half, over 1, up a half, over 1, up a half, etc. Okay, so the acceleration is 0.5 meters per second, which in a sentence means for every 1 second, the velocity increases by 0.5 meters per second, right? Because in 2 seconds, it increases by a full one. So every half a second, it only increases the velocity by 0.5 meters per second. Okay? All right, so that's going to be my acceleration. Okay, and that's how I got it from the graph. All right, and now let's go back and find the initial velocity because I think that this graph maybe wasn't quite right. So let's see. So if I go back in here, right, so every 1 second, right, it's going, let me make my table a little bigger. TEB. Okay, so let's work this back. All right, so every 1 second that passes, this velocity should go down, right, by 0.5 meter per second. Every 1 second, this should go down by 0.5 meter per second. Okay, so actually, this line should cross. Yikes. Okay, this line should really cross at 2. So it's a little hard. I don't have a grid here. And that's just as good. Okay, so that line should actually be crossing at 2. So the initial velocity is 2 meters per second, right? Because every 1 second, the velocity should go up by 0.5 meter per second, and then another second, which would be 2 seconds, it should have gone all the way up to 3. Okay, so you can either show this by the graph, but as what happened with me, you can see, be careful, because you might not draw it quite right. It's a little hard to draw, especially here when I don't have a grid. All right, and then here, it'd be probably better to explain it with the table, right? That you're basically sort of counting backwards in velocity to see what velocity it would have started at. Okay, all right, and then the last thing we need to draw is a motion map. All right, so let me erase this, I guess. Okay, all right, and I want the motion map to be roughly quantitative if you can, okay? So remember, this motion map is going to be based on the position, so I need to get all the way to 50, about. All right, so however you want to scale it off, okay, it depends on how it has on the sheet. So 10, 20, 30, 40, 50. Okay, so remember, these are meter marks, okay? And then my first point happens at 4 meters, okay? So that's about half. So maybe like around here, okay? And it already has a velocity of 2 meters per second, so it's going to already have some speed when I start looking, okay? And then there's a lot of points here, so I might just make a 2-second tick, right? So that I can just plot the points that are given, okay? Because otherwise it's going to be hard to fit it, okay? Because it's 2, 9, okay? And then 4, 16, 6, 25, 8, 36, and 10, 49, okay? All right, so these are actually going to be 2-second ticks, okay? So t equals 0, t equals 2, t equals 4, t equals 6, t equals 8, and t equals 10, okay? And then the new thing that I need to add is the delta v, or the acceleration vector, okay? So I'm getting 0.5 meter per second each second, okay? But really, I'm waiting 2 seconds, so I kind of need to add a meter per second. And I really don't care too much how exact these are, okay, but they should be the same size, right? That one looks a little long. Okay, so these orange ones should be the same size because this represents the amount of velocity that I'm adding, okay, which is actually 1 meter per second every 2 seconds, which is what this graph shows, okay? But if you get the arrows in the right place, the dots in the right place, I mean the arrows, and then you draw the delta V or the acceleration vector, I'm cool with it at this point, okay? All right, so that is how this should look, okay? Please, please, please make sure that you know how to do this. I posted another practice that I will put like an answer key for, okay? And then that'll be good, okay? And if you need help, make sure you come in and see me.